Recall the order of operations is a set of rules used to determine the sequence in which operations are performed in a mathematical expression. This ensures that everyone gets the same result when solving expressions. The steps to the order of operations are: first, perform any operations within grouping symbols, that is, parentheses, brackets, braces. If you have multiple grouping symbols, you always want to start with the innermost grouping symbols first, and then move out. Step 2 is we evaluate expressions with exponents, then we multiply or divide, left to right, the order does matter there, and then adding, subtracting, again, left to right. Let's look at example A. We don't have any parentheses or exponents to deal with, so we move on to multiplication, and we do have multiplication. Remember, to multiply fractions, we simply multiply the numerator and denominators together. So the numerator, 1 times 1, is 1, and the denominator, 5 times 3, gives us 15. Now we're adding. In order to add fractions, we need common denominators. Right now, the denominators are not the same, so we need the LCD. We need to rewrite these with a common denominator. The LCD of 15 and 2 is 30. List the multiples of 15 until you have a number that is divisible by 2. 2 will not go evenly into 15, but if we get the next multiple of 15, which is 30, 2 will divide evenly into 30. So 30 is the LCD. And now we need the equivalent numerator. 2 divides into 30 15 times. 15 times 1 is 15. 15 divides into 30 2 times. 2 times 1 is 2. Now we can add, since we have common denominators. We add the numerator, 15 plus 2 is 17, and we keep the common denominator. In example B, we have more happening. Notice we have an exponent and parentheses. We want to simplify inside the parentheses first. Inside the parentheses, we are subtracting, but we don't have a common denominator yet. So our first goal is to do that, get the LCD. So let's copy 3/4 squared for now. And inside the parentheses, we need a common denominator. The LCD of 4 and 12 is 12. Now the equivalent numerator, 4 goes into 12 3 times. 3 times 3 is 9. And 12 goes into 12 one time. 1 times 1 is 1. Now that we have a common denominator inside the parentheses, we can simplify. We can do that subtraction. 9/12 minus 1/12. We look at the numerator. 9 minus 1 is 8. So we have 8/12, which will actually reduce. Let's reduce at the same time we square this part. The next part of the order of operations is exponents. So we have 3/4 squared. Another way of thinking of that is 3/4 times 3/4. So we're squaring the 3. 3 squared is 9, and 4 squared is 16. Then we have divided by. Let's reduce this fraction. 8 and 12 are both divisible by 4. So we have 8 divided by 4 is 2. 12 divided by 4 is 3. Now we're dividing fractions. Remember, to divide fractions, we keep the first one the same. We switch to multiplication or change it to multiplication, and then flip the fraction. Keep, change, flip. Keep the first one the same, change to multiplication, flip the second fraction. And now with multiplication, we can multiply the numerators. 9 times 3 is 27. And 16 times 2 is 32. This does not reduce, so we found our answer. In example 3, we are making substitutions and then following the order of operations. We have 2 times z. Z is 5 over 6 minus x, which is negative 1/3. So we make our substitution, and now order of operations. There's nothing to simplify inside the parentheses, so we can move on to multiplication. Here we have 2 times 5/6. If it helps, think of that as 2 over 1. If we want to make that 2 look like a fraction. And remember that when multiplying fractions, we can reduce before we multiply. 2 and 6 have a 2 in common. So that will reduce. Each of those we can divide by 2. And now we can multiply. We have 1 times 5 is 5. And 1 times 3 is 3. And now we have a minus negative 1/3. Remember, when we have minus negative, we can think of that as a plus. Let's go ahead and do that. Notice we now have a common denominator. We are allowed to add these since it's a common denominator. The denominator stays the same and we add the numerator. 5 plus 1 is 6. And finally, 6 divided by 3 is 2. In our final example, we first need to make a substitution. Y is 2/5 plus x is negative 1/3, all divided by z, which is 5/6. Notice we have a complex fraction here. To simplify a complex fraction, we look at the interior fractions, the smaller fractions, and find their LCD and multiply the numerator and denominator by that LCD. So the LCD of 5, 3, and 6, that LCD is 30. So we're going to multiply the numerator and denominator by 30. Looking at 2/5, 2/5 times 30. 5 goes into 30 6 times. 6 times 2 is 12. And now negative 1/3. 3 goes into 30 10 times. 10 times 1 is 10, and we'll make it negative, since it's negative to begin with. And in the denominator, 5/6 times 30. 6 goes into 30 5 times. 5 times 5 is 25. Now looking at the numerator, 12 minus 10, we have 2 divided by 25.